Hello everyone. So today we are going to implement a simple terrain generation method in runtime. So now as you can see, when in the level I don't have anything, but in the runtime a simple terrain is generated, as you can see. So it looks basic for now. We will continue to improve that, but this is the starting point. So it does have some borders and some unevenness in the terrain, and also this is the blueprint. Everything is done in blueprint. Perhaps later on we might have to move into a C++ for performance issues. I'm not sure, but for now I just wanted to test this with blueprint. So here we can change the vertex count. So if I want, I can make it very small, and cell size, this will define the size of polygons. If I make it 100, now terrain is over there. See, this is all that we have. So yeah, just like this. If I want, I can make it larger. So it's too spiky. It's not easy to navigate. So if I increase this cell size, let's say 300, it would be more soft like this. Okay, so this is what we are going to implement today. The long-term goal is creating an infinitely generated landscape. I'm planning to use this with my spaceship system that we were working on in another series, so that we can infinitely roam in the world, around the world with our spaceship. So before we get started, I'd like to remind you that you can download the project files of this project and all other thousands of projects that I have done in my channel in the Patreon page. I'll leave the link in the description below. So all you have to do is becoming a member. Once you are a member, you can download everything without a limit. So feel free to check it out. And let's get back to the tutorial. This was the spaceship system I was talking about. Okay, so the reason I thought of implementing a runtime terrain generation system is because I hope to create an infinite landscape for my spaceship project, because I want to implement something like a planet, so that we should be able to fly in our ship infinitely, like maybe round and round. So I'm not sure I can achieve that with the current landscape system that we have. It could become too heavy, and also anyway, I want to try this. So let's see what we can do, or how far we can go. And I did look into how to implement a runtime terrain generation with this existing landscape system, but I couldn't really find anything about that also, because it seems like most of the things are designed to work on editor time, not in runtime. But I could be very wrong, so don't take my word for that. Okay, so let me create a new folder. What should I call it? World generation. And let's create an actor. pp world. Okay, so here, so since we can't, let me first create a new empty level, basic level, and delete this flow and drag and drop this world. Right, now to generate a terrain, we need to generate a mesh. So I hope you know what a mesh is. If you are thinking about terrain generation, yeah, basically any 3D surface or box or anything. So right, so how should we go about this? So I should say that maybe we will have to switch to C++ later on and maybe run this terrain generation part in a separate thread or something for performance use. But for now I just want to figure out how to create some terrain in the runtime. So let's not complicate things today. So let's just see how far we can go with blueprints. Alright, so I'll create a function, not a graph, function. Generate terrain. Okay, so we need a procedural mesh component, a procedural mesh, because this is where we add, call it terrain mesh. So this is what's going to be our terrain mesh. Now in this terrain mesh we have a function called create mesh section. So if we call this function with a set of vertices, triangles, vertices and triangles, this will create a mesh for us. But first we need to learn how to create vertices and triangles. Therefore, without worrying about the actual terrain generation part, let's develop a simple function to generate a set of points in 3D space. So I'll add a variable x vertex count. It should be an integer. So we need vertices. So we need vertices in 2D space, in 3D space of course, but this is gonna be, initially it's gonna be a plane, and y vertex count. I'll make this public so that we can change these values in the editor and test. So x vertex count, I'll put 5. Y vertex, I'll put 2, so that we have some difference, so that it is easier for us to identify which one is which direction is which. And for this function, I'll call this function in the begin play generate terrain. So I'll give these values. Well, for now I don't have to implement parameters. I'll just directly use these inside the function. So let's run a for loop. For loop. Starting index is y vertex count. Actually, if I say the vertex count is 3, then since this is starting from 0, we should run until vertex count -1. Okay, so that's the last index, and inside this another for loop. This one for x, so same as before, x vertex count subtract 1 from 0 to that. Okay, I'll add another variable. I'll call it cell size. So this represents the length of one section of the mesh. By section I mean one polygon. I'll make it a float, and as the default value I'll choose 0. Okay, now we need, as I said here, we need an array of vertices, means an array of vectors of locations. So what's the name used here? Create section vertices. Okay, I'll promote this to a variable, and triangles also I'll promote it to a variable. Normal, let's worry about that later. Okay, so once we have this is our x index, and we need to multiply this by the cell size. This is our x value, and this one also need to multiply by the cell size. So this is y index. So to our vertices, let's add one element, and I'll split this. I'll keep z as 0 for now, so it would be a plane, but that's fine for now. Later on we can add mountains. So right now, just because I run this, we can't see anything. Therefore I'll draw a debug box, and the center would be this newly added vertex. Let me split this. X, Y, and z 0, extent maybe 2, 2, 2, and maybe red. Duration, I'll keep it 100 seconds. 2 thickness. Okay, compile, and we are calling this in the begin play. Now if I simulate, see, now we have a set of points. 4 by this side 5, which is x, this side 4. Is that the values I put? Wait, I put 2. Something is wrong. Sorry. This should not be minus, because we are already subtracting. So plus 1. Okay, now it's correct. 5 by 2. So these are the points. So now we do have a set of points, and here if I make it 3, now we have a point like this. Now we know how to make the points. Now we need to generate, we need to fill this triangles array in order to have actual polygon. So let me make this public so that we can see what kind of values we have. And okay, now once these two loops are completed, I'll get the terrain mesh, create mesh section, and let's plug vertices and triangles. Other things we can leave. for now. Now nothing would appear because we don't have anything in the triangles. For the vertices we have these values. So if I simplify this, no need. So in order to add a face, we need to define triangles, and for that we need to give 3 points starting from here. It's not clear enough. From here, this one, for example, this one and this one. So I think we need to give, I don't remember if it should be clockwise or counterclockwise, because depending on the clockwise or counterclockwise, the given vertices order, it will either draw the face on upside or downside, but we can test that. So here you can see, let me make this smaller, 3 by 2. Okay, now this is 0, this is 1, that means this one, and this is 2 means this point, and 3 means this point. So if I put 0, 3 and 1 into this triangle, into these triangles, it should draw one face. Let's test that. I said 0, 3, 1. See? Yeah, it should be counterclockwise. Okay, and if this one is 4, if I put, which one is it? This is 3. No, yeah, this is 3, this is 4, this is again 1. 3, 4, 1. If I put 3, 4, 1, let's see. We should see a full box. Yeah, nothing from this side, but from here we can see. Okay, now we need to write a logic to fill triangles, determine triangles for each to connect each of these points. Okay, so let me delete this. Now this is generate vertices. Next part is going to be about generating triangles. So if I go back here, to start drawing a triangle, we should first identify this one, these vertices. These are the only vertices that we need to start drawing the triangles. So let's first write a logic to identify these points in our vertex array. So again, so here, wait, we don't need these and these two. We only need these points, because here we don't need to draw another triangle because there is nothing above these points. So yeah, they are not required. These are the only points that we are interested in. Okay, so for that, now we need a similar kind of a loop, but in this case we would not need, we need to connect here. We will not need to go to the last one, so this should be -2. So if we check here, this is actually x0 y1 x1 sorry x0 y0 x1 y1 x2 y sorry x0 y0 x1 y0 x2 y0 x3 y0 here x1 x0 y1 x0 x1 y1 x2 y1. So as we go up, y stays same and x is what's changing. So in a one-dimensional array, so this would be just incrementing with x. But if y is 1, that means it would have y amount of length of x vertices plus x coordinate. That would be the index. So to x, it will be clear when I do it here. So here we get the x coordinate. Let me put this as x. Oh, it crashed. Okay, we are back. I redid some of it. So I have marked this as ix because index x and iy because index y. Now according to what I explained in the diagram, the points that we are interested in for now is this value plus this value multiplied by x vertex count. Okay, and if to see I'm correct, we can first, let's add this value to our triangles. So this is the first point. We need 3 points to have a triangle. But first, to see if I'm correct, let me draw debug line with the value found in this index we calculated. That's the start and end. I'll add 50. To duration 100. Now if I run, so here 5 and 2 vertex count. Okay, see, now we have these are the points that we need to start drawing the first triangle. If I make this 3, this is wrong. We should have these 3 as well. Oh, sorry, I should have used x vertex count here. See, okay. Now we have the starting point of triangles, some triangles that we need to complete the mesh. And the next point we need is, if we start with this one, obviously the next one is this one and then this one. If we start with this one, first here and then here and then here. Okay, so that is actually, for example, if I go back here, let's say, now let me get another screenshot. Okay, now if I start from here, this is first, second and third, and this will come here, but we don't have to worry about that. So this is x1 y0, So 1, 0. This is x1, y1. So 1, 1. And this is x2, y0. But if we consider a linear array, one-dimensional array, the difference between this point and this point would be the length of number of x vertices, because this one 0, 1, 2, 3, 4, 5, 6. See, so this is 1, this is 6. 6 minus 1 means 5. That means this x vertex count. So the next point, our next point is this point. We already know the first point, plus x vertex count. Okay, now I'll draw that, and also I'll add that to our triangles array. So this time we should be seeing this one, this one, this one, this one, this one, sorry, not that one, and this one, this one, this one, this one, these things with lines. Let's see. Yeah, see. Okay, so the second point is complete, and the third point is just whatever this one plus this plus 1, and whatever this one plus 1. So that's easy. That means another add. So as I said, this one plus 1, and I'll give this value here so we can see that as a line. Correct. Okay, so now we have a set of lines, set of triangles identified. So we can, it will not be a complete mesh, but we can fill some of it. Now if I just complete here, connect here, wrong. Oh, here we haven't connected. Okay. See, now we have the half of it. And now that we know the indexes for the triangles of these, it's easy to identify the next one. So we already know this one and this one. So this one would be simply this one, index of this one plus 1. So before that, let me make this 4 and see. Yeah, it's working. So here, now let me duplicate this part, and I don't need to draw the lines anymore. So first point would be this one, and then this one plus 1, and then the third one of the first triangle. So that means this is first point, and this plus 1 would be the second point, and the third point of the last triangle. Correct. Yeah. See, now we have a complete mesh. Okay, so now I'll remove this debug box also. Let me just disconnect that, because we are going to increase the size of the terrain to test. 30, 50. Now let's make a square one. 50, 50. Yeah. Now here is the terrain. If I enable wireframe, now you can see the mesh. So, alright. Now, if I want to work on it, we will have to create collisions so the character can walk on it. To test that, let's add third person character and change the game mode to third person game mode, and let's start from here. Oh, we are simulating. Right. So if I put something like 500 and play, now it's pretty large. Okay. Now if I go here and instead of directly inserting these XY values, yeah, XY value is fine. For Z, if I use a Perlin noise. So Perlin noise means generate a 1D, one-dimensional Perlin noise from the given value, returns a continuous random value between -1 and +1. So we will not have any break-ins, so we will get a smooth landscape and nothing will be broken in between, because this value returned will be continuous. So I will multiply this by maybe 200, no, 500, we can check that. And as the input, because this value is going to be in between -1 and +1, so that will not be noticeable if we don't multiply it with anything. So for now, if I put here, it's flat. Oh, I remember I had, it should not be, we should not sample it in integer values, something like that, I remember. So I'll add a decimal value, say 0.1. Yeah, now we see some shapes in the terrain. If I enable F1, you can see the difference, and it's it doesn't change across, it changes only in one direction. That's because we are only using this part. So what if I do the same thing and add these two together? Now we have some mountains. Okay. Now if I here, let's assign a material. Set material and I'll choose this my prototype grid gray. What is this? Let's use the other one. So yeah, it does have material now, but yeah, so we will continue to do more improvements to this terrain because I want to make it infinite. That's one thing, and also I want to make it look nicer. For now it doesn't look very nice, it's just basic, but I'm gonna stop this episode at this point for today. And as always, project files will be available for you to download in the Patreon page. Link would be in the description below. And see you in another episode. Goodbye.